Hey, good morning. My hair is so crazy looking. I don't know if you ever watched David Letterman. Towards the end of his career, he'd come out and he'd be complaining about his hair. My hair is doing something really weird this morning. Anyway, chapter 3. We are going to be talking about energy here in the first part. This is the part 1 of chapter 3, which is energy usage. So we're going to get right into our discussion. And first of all, what is the definition of energy? You need to know it. It is the ability to do work. That is how we define it. And energy can take two forms. And those two forms are going to be potential energy, like the rock up here that Coyote is getting ready to push off the cliff. And it can also be kinetic energy, and that is energy in motion. So as the rock is falling down towards the Roadrunner, that's from my youth. Maybe you guys know who Coyote and Roadrunner are. Maybe not, but the analogy works regardless. So when energy is stored, like in a battery or in high energy molecules, this is a biology class after all. So when energy is stored in sugars in that candy bar that perhaps you ate or are getting ready to eat, rather, that would be potential energy. And then if it makes you crazy because of all that excess energy, that's energy at work, kinetic energy. And so this energy is going to be switching back and forth between the two different forms. Now, if we were talking about, if this was a physics class, we might be talking about the units of energy being something like joules. And a joule is the amount of energy that is required to lift 100 grams, kind of like an apple, 1 meter. But we're not an energy class. We're not a physics class. We are an energy class. We're not a physics class. We are a biology class. And so in this class, when we talk about energy, look at your candy bar. What are the units? Calories. So in biology, we think of, we measure energy in a different manner. It's not that unlike the physics measurement, joule. But in the case of calories, a calorie is the amount of energy that is required to raise the temperature of 1 cubic centimeter of water 1 degree centigrade. Now, you're probably thinking a cubic centimeter. What is the term? We abbreviate cubic centimeter cc. So if you think about a shot and 1 cc of water, the amount of energy that is required to raise that 1 degree is a calorie. Now, that doesn't take much energy. So in reality, when you look at that candy bar and it says it has 200 calories, in reality, that's 200,000 calories, because a calorie is actually so small. In the food industry, they have decided to just cut off that kilocalorie, and it's understood that on any food packaging, when it says 200 calories, it's really 200,000 calories. But anyway, so that is what we are going to be talking about today. A little bit is about energy. And I'm 4 minutes into here, and 2 slides in. So I'm going to stop right here, and we'll set up and do it again.